Hey, hello everyone. I'm Su Yuxiao from Shandong Institute of Advanced Technology on behalf of RASER team. Today I will give a brief report of RASER, a Python-based detector simulation software. Here's the outline. The report will be divided into these 5 parts. RASER, short for Radiation Semiconductor, is the first simulation software for semiconductor detectors. It aims to estimate both spatial and timing resolution for silicon and silicon carbide detectors, providing predicts for detector design. It relies on DEVSIM and Geant4. We can simulate IV-CV distribution by DEVSIM, and it also allows us to get electric and weighting field distribution. Geant4 helps us to get non-uniform charge deposition. Based on the field we get from DEVSIM, we can calculate the induced current by Shockley-Read-Hall's theorem. We have some research based on RASER published. As you can see here, we study the timing resolution of silicon carbide planar detector fabricated by Nanjing University. The epitaxial layer is 100 micrometer. And this is the experimental setup of timing resolution system. 2 detectors are vertical placed along the direction of charged particles from the beta source. One is the detectors we've concerned, and the other one is a reference detector with good timing resolution. You can see in this plot, the RASER simulation is close to experiment data, and we also put TCAD result here for comparison. The simulated timing resolution we get from RASER 73 picosecond is rather close to what we have from experiment 94 picosecond. Another interesting work is about 3D detector. Simulation tool plays a more important role in such area because we are now not able to have a real detector like this. The electrodes are vertical to the surface, and the drift direction of carriers are different from planar case. That means the probability for carrier caught and drift distance decrease. Based on this, we could have better timing resolution. Besides, number of electrodes and the distance among them can be easily simulated, and this will help us a lot in production process. Here's the framework of RASER. We define the detector and define spatial information for experiment facility, the way of matter interaction to get the particle track in Geant4. The Python bindings for Geant4 depends on G4PY, and define mobility of materials and avalanche model. Solve electric field and weighting field in DEVSIM. The process of solving electric field is complemented by creating a mesh, defining the doping, and incorporating models such as Shockley-Read-Hall model and Hatakeyama avalanche model. In DEVSIM, equations are transformed into integral forms and solved. And also you can simulate IV-CV information here. Then in the calculation part, carriers, drifts, and gains. The induced current can be calculated according to Shockley-Read-Hall's theorem. Then we add the electronics. Of course, we can input noise from experiment, or we can input circuit simulation like ngSpice. Here I list several aspects we are focusing now. The first one is the electric field estimation for detector with gun layer, like silicon algate used for Atlas upgrade. We optimized the inject laser beam and carrier movement, as well as the electrical readout, aiming to achieve the goal of predicting experimental result. The second one is to extend DEVSIM to 2D solution. Then we can simulate strip detector. Considering the silicon algate work we've done, it's doable for us to simulate silicon carbide detector with gun layer, which means we can have the timing resolution and spatial resolution at the same time. The third one is to extend DEVSIM to 3D solution, and then we'll be able to simulate pixel sensors with gun layer, of course, and we can put them in telescope to do track reconstruction. Here this summary. Hope you have some understanding of the simulation software RASER based on Geant4, DEVSIM, and other simulation tools. It can simulate multiple detectors and the result reasonable. The electric readout for users is very flexible. You can use experimental noise as input. Also, you can use ngSpice or some other to simulate the readout circuit. It's also capable for more detectors and systems like irradiation defect for all of the semiconductor detectors. That's all. Thank you.
Thanks very much for the talk. So we definitely have time for questions. So let me check the chat to see if there's any hands raised. Oh, I see one from Eduardo. So Eduardo, please go ahead.
Hi. Yeah. Well, this is not at all my field, so just a naive question, which is, are you in collaboration for these kind of tools with, say, the RD collaborations at CERN, so RD50 and similar collaborations that work also on semiconductor technology? Is that something that you have, or this is something that you have, say privately in China, but this is not being used?
Yeah, this is Xin. Maybe I can comment here, Eduardo. Yes. So actually, in fact, it's exactly true. So basically, we started with the micromodel, the RD50, and with our colleagues there. Our student has been there for half a year. We're working with people there, starting with the tracks. And we tried to begin at the beginning. We tried to do the similar thing, but later on, because we want to do something of the silicon carbide, so we ended up with the this Python-based way versus the C++, because it gives us a huge benefit when we're recruiting undergrads. They like Python. It's very easy for them to understand. So that's why we ended up with this framework. It turns out very very efficient, particularly with the Python binding with this ++. So all the software on the line, we choose the one which have a very user-friendly for the Python bonding, for the Geant4 and the DEVSIM, this kind of thing. Yeah. So yeah, we started with there, but later on it's a good combination with them. Yeah.
Okay. Yeah, thanks. I was just curious, Leslie. So okay.
Yeah.
That's good. Yeah.
Maybe I can ask one quick follow-up question along that. Since some of the dependencies that RASER has, like as you point out, like Geant4 and others, and these seem slightly large. I can imagine that for like new students, it's probably difficult to install some of the things. So yes. Do you usually use like CVMFS or something to try and set up the rest of the dependencies, or is there a recommended way for people to kind of get started?
Sure. Yeah, that's a good question. I can talk this for days. Okay. So basically, exactly, that's a very good question. It's very practical. So several years ago, we tried to do some naive way where we hope students can learn with their laptop, run some some virtual machine, but it turns out to be a disaster. It's not easy. So right now, what ended up is we maintain a virtual machine based on the Apptainer. So it runs on our local server. so where it can be submitted like a job. So another one we based on that we use choose the Debian as a kernel and then build on top of this one. So basically we have one, or basically right now it's me actually to maintain this this image so that everybody else can just run run on top of that. So on this side, since you asked this one, it's actually also something I think as a community here we have to help. For example, right now in terms of Geant4, the version we have been published papers was based on the 10.7, and recently I was trying to upgrade to the Geant4 11. It turns out they have dropped their Python binding somehow, so it was really painful to migrate. So at the end, I said, okay, let's wait for some time to get this done. Yeah. So basically, I think the bridge between the C++ and Python is something as our community here. It's a good if we can, have some team or people to work on those. It'll be great. Yeah. Somehow the Geant4 team they started to drop that one. Yeah.
Yeah. That's yeah, very good point. Okay, and let's see if we have any final questions. Looks like no, so let's thank our speakers again for the